Next, we are excited to welcome Aamar Hussain, Director, Azure Data and AI at Microsoft. Aamar is currently Senior Leader within the Microsoft Azure Customer Success business, responsible for Data and AI Cloud Solution Architects. The Data and AI CSA team mission is to empower customer value and realization using Azure Data and AI portfolio. Prior to Microsoft, Aamar led the contact center AI practice at Google, working with key strategic customers and partners to create and execute on customer experience transformation vision using Google AI and ML. Aamar holds Masters of Science in Information Systems with over 18 years of industry experience centered around engineering, consulting, and enterprise solution architecture in a variety of verticals, working with Accenture, BT, and DXC, previously known as CSC, leading with a curious and student mindset, seeking out opportunities to make a positive impact to society. Passionate advocate of making sure technology, data and AI is a force for good in helping combat some of the biggest problems in our and the future generations to come. Following, Aamar will talk about why data is at the core of AI and ML. Aamar, the microphone is all yours.
Well, thank you so much for that great introduction. I really appreciate that. It's so great to be involved in this program with all of you with this series of webinar. And I think the team at Wow AI have done a fantastic job. I'm sure you've enjoyed all the participants and all the speakers that have done the talks earlier on in the day. So here we are. This talk for myself, we're going to basically focus on the topic of the talk today is on kind of why we need to maintain focus and attention and kind of emphasis on the data when we're starting our next AI and ML project. So thank you so much for the introduction. I'm really excited and looking forward to doing this talk with you guys and sharing my ideas and views on this topic with you. So first of all, I want to cover off some key topics and key discussion points that we're going to talk about in this particular session. We're going to actually try to unpick why is data such a critical phase in machine learning and AI process? What's the kind of some of the drivers, the purpose behind understanding that kind of critical phase? I know it might seem like an obvious thing to do because, you know, everybody's spoken about this before and we've heard a lot about this, but actually what are the kind of key drivers and reasons behind, data being such a critical phase for machine learning and AI process? Now, the next thing we're going to look at in this session is around kind of building a custom ML model using natural language processing, natural language understanding to automate customer experience. Now, this is a real life use case study that I was personally involved with myself, which I led with a fantastic team in Google to do this. And I want to show you some examples of some of the challenges actually you could have when you are not focusing hugely on the data and you're kind of more focused on the other aspects. So what are some of the kind of best tips and examples I can show you? And I'll bring this out in this case study that I'm going to talk about in our session shortly. The next section, we're going to talk more about the kind of, I'm going to use an analogy of data being the food for AI and cooking up the best meal ever using this data. So think of data as the kind of ingredients, the fresh ingredients that you have when you go into a meal, when you're looking to cook something. It's a similar situation with AI, right? Data is the fuel, is the kind of quality organic ingredients that you need to have in place to have a fantastic, delicious meal or a successful AI product, shall we say. And then I'll talk more about the best practices and recommendations. So what are some of the tips, some of the best practices that I can share with you to hopefully help you build a framework or a process for your next AI and machine learning project. And then I'm going to try to bring it all together and provide a bit of a summary in terms of what the framework of the process might look like for the data quality and data management and the data kind of maintenance aspect of of the data piece of doing machine learning. And then we'll have a couple of question and answers at the end as well for us to kind of speak and for me to speak a little bit about that. Um, so let's start. Actually, let's go and start with looking at some of the reasons around why we need to kind of maintain focus on data and what have you. Now, an AI and ML system basically is made up of data and code, and by code, what I mean is the neural network architecture or the algorithm that you may choose that is then trained on a data set. And that's the way that kind of ML has been developed over the last few decades is to actually a lot of the progress has been made by downloading a set of very generic data. So going on GitHub or finding the latest data set in Kaggle or one of the other sources that you have, and experimenting with that data set with a view to fine tune the model and the algorithm. I fine tuning the code that you basically have within that model for that model, and finding and optimizing that. And what we're finding now, though, is with a lot of a lot of the work that we've been doing and a lot of the work that I've been involved with, actually, and I've come to realize that actually the focus should instead be on improving the data instead of the kind of model tuning and what have you in a systematic way, and to build a more kind of more learning or more better learned machine learning with a much better performance and accuracy rate for that particular project. So, that's one of the key areas of emphasis and focus that we have right now is kind of actually changing the focus from a model driven to a more of a data driven approach where we look at the data in more detail and we kind of work on the data iteratively to get a better performance and a better accuracy from that model. So that's what number one. Number two, I mean, it definitely goes without saying that garbage in is garbage out. Now, there's no more a kind of true saying of that in actually in AI and machine learning, because at the heart of all this, right, machine learning and the AI process heavily depends on good quality data. And it also, think of that data as the kind of lifeblood of any ML and AI system. So machine learning algorithms are very dependent on accurate, clean, and well-labeled trained data to learn from, so that they can produce, give you more accurate results at the end of it. If you train a machine learning model with poor quality data that's not clean, that's very noisy, you're going to either have to do a lot of fine tuning and pre-processing, or to no surprise, you will get garbage results, right? So it's garbage in, garbage out, basically. And it's for this reason that the vast majority of the time spent during your AI project is actually doing the data collection, the cleaning, and the preparation and labeling phase of that data. So the majority of the work in any machine learning system, and you may know, is actually on the data aspect. Now, according to a recent report from a research and advisory organization, over 80% of the time spent on AI projects are actually dealing with wrangling data. Even more importantly, and perhaps surprisingly, it just shows you how human intensive much of this data preparation work is. Now, for example, in order for supervised forms of machine learning to work, especially the multi-layered deep learning neural network approaches, they must be fed with large volumes of example of correct data that is properly annotated or labeled with the desired output result. For example, let's take an example here, a very simple basic example that we're all familiar with. If you're trying to get a machine learning model algorithm to correctly identify, say, cats inside of images, you need to feed the algorithm with thousands of images of cats appropriately labeled, with the images not having any noisy or incorrect data or inconsistent amount of labeled data, which will then basically throw the algorithm off as you build the model. So this is really important phase, within machine learning. And really the key standout message here is that if you feed in poor data into your systems, you will get very much poor results at the end of it. So the emphasis really is big on this. Now, in terms of the kind of key area that I think why we need to keep momentum and focus on data is a little bit on some of the points that I'm mentioning over here. Now, look, more data is not always the answer to resolving all your problems, right? Now, there are areas, for example, there are organizations who have access to plenty of data and a huge amount of data, who then have the resources and the capital and the finances to be able to train and utilize that data to build AI machine learning models and algorithms which can serve millions of users who they can utilize to make revenues and justify the ROI. Now, some of the key points here around why I think we need to maintain focus on data is that we can utilize some of the development and some of the advantages of keeping and maintaining focus on data to address some of these big problems. So, for example, some of the issues or challenges around training large models. Now, some of these models are huge, like 17 billion or 19 billion parameter models, large language models that you see up there. Now, we need to think about how they impact some of the biggest challenges that we have as a human race that we're trying to solve. For example, sustainability, right? When we need to kind of understand and think, what are we doing with this huge amount of training of language models that we're training? How much carbon dioxide is being pumped out into the atmosphere as a result of these? I mean, some of the facts that I came across, which is quite eyebrows raising to say the least, is some of the costs behind this. So if you look at a large kind of average large type of language model, you're talking about over 600,000 pounds of carbon dioxide being put out into the atmosphere, and the energy costs for these kind of things. I mean, look at they're going to millions. For a typical, for example, GPT-3 learning model, you can see how much these things cost to train and to kind of impact resources on these. Now, we need to be very mindful of these things. We have to be responsible to the world that we live in, and what we are doing to this world and for our next generation that we have here. So one of the ways that we can come out of this, or one of the ways that we can address this problem, is actually by um, understanding and actually treating the data that we do have to build the models and algorithms and machine learning that we need to do in a much more efficient, much more convenient, much more kind of much more smarter way of doing things, using small amount of data rather than huge amounts of data to get somewhere close to the right, somewhere close to acceptable level, or even very well very well amount of a required level of performance that you need from an AI model and what have you. Now, the graph on the right that you see, that is basically the AI index, which follows 55 kind of public policy groups within the US, and they publish papers related to AI. And the chart shows the topics that these groups focused on last year. Now, I'm kind of using this chart as an excuse to raise the topic of AI's increasingly large energy footprint, which I covered earlier on, around training big models, like taking a huge amount of compute time and therefore potential to impact the kind of climate implication that I spoke about. This is something that is being raised highly at the moment, rightly so, and it will continue to take precedence and kind of continue to take a top spot on a lot of the research that you will see coming out in the coming times around the kind of how can we measure and collect data on compute efficiency and climate kind of impact and what have you. So I just wanted to raise this as a very important aspect of why we need to keep the focus on data rather than moving away and thinking that we've got infinite amount of data that we can train on and utilize. We need to be mindful of that. Now, the next thing that I want to focus on here is around the kind of a data-driven approach, let me start with a kind of example or a use case that I worked on to showcase and to give you an example of a data-centric approach coming to life, and some of the challenges that you have with when you don't have a data-centric approach, or some of the things that you can come up against. So now, basically, the case study was around a customer project that I completed not too long ago, around building a data-driven customer experience transformation project for a large financial organization. And one of the steps in that was to collect data. So we were doing a data-driven approach, and we needed to have data from a large number of audio calls, and then have that data transcribed so that we can reuse that data to train a custom natural language understanding, natural and custom NLU model for that particular customer. And one of the tasks we had to do there was, once we'd done the task of a very difficult task of actually, first of all, building a business case to say, why this kind of thing can have a huge amount of impact on what you're doing at the moment. What's the ROI behind what we're trying to build here, and what's the value proposition behind all this? Once we had that convinced, we had to actually go and try to come up with a request to say we need X amount of data. And the question was, why do you need huge amount of data from us to be able to do this? And the answer was, because we want to give you a highly accurate, highly performant NLU, custom NLU build, so that we can help you achieve some of the automation containments that you're looking for within your customer experience, to have a real impact and kind of create the value that we want to create and create the impact that we want to create. And the key pre-dependency for that was the data. Now, in order for us to have that data, this had to be, first of all, signed off by some of the more senior execs within the business on the customer side. Those customer execs would not sign anything off until they have gone through a fully fledged data security, data governance, data compliance process, which met to the highest standards that they could push us through to achieve. And that took me something around 6 months just to achieve the compliance and the governance and the approval process, after a continuous amount of, or multiple amount of reviews from the CISO office of that particular customer. And even then, we got a very small amount of data which we could utilize, highly redacted, highly anonymized data, which we could utilize to train a model which we can utilize to showcase the value back to the customer. Now, some of the challenges with this were around, if you look at the script on the left hand side, that's one of the kind of voice call one transcript. The yellow labeled, or the yellow highlighted label is labeler 1, and then a green highlighted label is label 2. Now you can see that in caller 1, when the job of the labeler was to pick out an intent and label that intent accordingly. Now each labeler has a different idea of what the intent is. Now in the first instance, you see there, I need to check what my outstanding balance is on my account, for example. The caller 1 says, the labeler 1 picks up that as an intent of being outstanding balance. At the same time, labeler 2 picks that up as an intent of being check balance. See, that in itself there is not contradiction, but it's two different inconsistent ways of labeling that particular intent from that data. And that carries on and the next turn of the conversation, where you got the payment outstanding balance being classified as pay balance and pay outstanding by two different labelers. See, the both labelers could be right in their own right, but the problem you're seeing there is both of these examples, and the other side as well, the examples where you've got three labelers. So as you are pushing more labelers to label the data that we've transcribed from the calls that we've got in that process, the challenge we're getting here, and the problem that I'm trying to articulate here, is that you will have inconsistencies in how you are labeling the data, and that will have a direct impact on how the direct impact on the accuracy and the success of your learning algorithm and your model success at the end of it, and the criteria that you have there. So one of the key challenges we came up against was that the amount of time the labeling and relabeling had to be done to achieve a certain level of performance. Now, look, one of the things that I want to do is actually now I want to ask you as the audience a question here around this particular challenge that we had. Now, the baseline accuracy that we got was around 75% for the intent capture from multiple labeling of the data that we've transcribed from that particular use case, or the case study that I spoke to you there. The target accuracy was above 90%, so it had to be above 90% to create the kind of impact that we were looking for and the ROI that we needed to hit for that particular case study in order for the customer to be convinced to be able to take this project on or to see the value from this project. The question I have for you guys now, I've got a bit of a question for you, is to say, well, so the question I'm going to ask the audience here right now live is, what should the AI team do to improve the NLU model performance? And you have two options. Option A, look to improve or replace the model, where you're going to go away and find a different model, or fine tune the model to see if you can build a better hyperparameters, or do some hyper, better tuning of different parameters, and you've got, what have you got there? Or option B, where you look to find additional audio calls and transcribe and transcript the calls to bring more data into the model so that they can learn from more data. So add more examples of the call transcripts, i.e. more data. What options would you select? Can we go and ask the poll, please, from the audience, and see what you are getting in terms of the two options? And we'll just give this a minute or so to see if we can get what kind of results we are seeing or what we are getting from the two options. So please go ahead and give me your answer. And I'm really intrigued to see what answer I get from both of those options, and then I can tell you a little bit more about some of the results that we did find from this. So please go ahead and provide the answers. Okay. Oh, interesting. It's a bit of a seesaw going on here. I'm seeing live results come in here. It's very interesting. Very, very interesting. So let's just keep this poll going for a second and see where we get to. At the moment, we're getting something like 45% people saying, 45% of people saying look to replace the model or improve the model, and then around 55 people are saying kind of around the give more data, basically provide more data. So a little bit more on the data front compared to very kind of similar results, and I'm a little I'm quite kind of surprised with the results there, not because I think it's wrong or right or anything, but just how how certain people's perception is around kind of what needs to be done. But let me share some of the results with you from that activity in terms of what we saw and what impact we had from actually doing something different. So the results that you see here is what basically what we had to do to improve the baseline performance to get that. So when we did a kind of model-based tuning or improvement, or if we tried different model and algorithm or what have you, we did try that with an engineering teams and what have you, and we found almost 0%, almost no improvement of performance of the NLU for the virtual agent. However, when we took a database approach, we found almost up to 20% improvement in the model accuracy and in the model kind of behavior. And so, giving more data and having much better kind of data practices of labeling and consistent labeling, I must say, consistent labeling made a big difference in terms of the result of the end. So, this goes to show you that using a data-centric approach actually will get you a much better accuracy by using good quality data, even though you can try different using different hyperparameters, tuning, decent learning rate, decent regularization parameters, etc., trying different neural architectures doesn't really have a huge amount of impact in comparison to how much of an impact the good database approach will have, or more data-centric approach can have on your particular model and your performance. Now, when we speak about kind of data being the food for AI, when I speak to different people and what have you, the people I tend to use this analogy sometimes about how we can cook a really delicious meal, with using high quality organic ingredients. Now, one example of this is that I love having my traditional food cooked, especially cooked for my mom for a long time, and I've always loved that. And I have still memories of in my native land back home in Pakistan when we had food that vegetables that actually tasted very nice in comparison to the food that I have here now and then where I live right now here. And the reason behind it is the ingredients. I found out it's the organic ingredients that you pick up and that you use when you build a really when you taste a really delicious meal. It's the same analogy for machine learning and AI, right? You just like you could pick up any kind of all like food, any food that's been in the fridge for any ingredients that's been in the fridge for a long time, and build a meal which will taste okay, it'll cook and what have you, but it won't taste. The quality of it will not be the same. It's the same analogy, same idea with machine learning. Sourcing and preparing high quality data to train your model will make a big difference, and that is actually the bunch of the work. 80% of the time, that's what makes all the difference. And then training the model is the rest of the 20%. Now, if you look at the question I asked earlier on, if you recall, I had a kind of 50-50, a little bit more on the data side, I guess, and also the results that I showed you in the slide before. When you see the database approach, it had a massive impact on the performance and the accuracy of the model, as you can see here. Now, the research, and I did a bit of research into understand where is the kind of research focused and what's the shift in the research side of things. It was quite interesting to find out actually that the majority of the research was on the training the model aspect, on how you can make a better model, how you can tune, how you can create a lot of better fine tuning of the model. That's where a lot of the research was focused on, rather than being focused on the data aspect, where the data-based model and the data-centric approach is actually more important, as we know, but the research is quite, the opposite. So that's something that needs to be looked at, right? I mean, for many years we've been telling everybody in the industry that 80% of the data, 80% of the machine learning is all about cleaning the data and having the data prep done and what have you. Now, the importance of improving the data has been widely discussed, but we would love to see a shift. I would love to see a shift in more kind of research being done on the data aspect rather than on the model aspect side of things and what have you. So that's just a kind of key observation or a point to highlight and kind of articulate where the focus needs to be going forward in terms of research on a more data centric approach. When you're thinking about building a machine learning model project in terms of making data prep systematic, we need to think of a process or a framework. And this framework that you see here is something that I I'd seen and kind of researched into various different industry specialists and industry kind of thought leaders, and you can and the following is kind of a very condensed version of that process and very kind of summary or a summarized version of that process. And think of this as a ML project, as a life cycle where you start off with framing the problem, right? Normally there's a lot of emphasis in jumping straight into training the model, or training error analysis, or iterative improvement, and that's just one step of the entire life cycle of the ML project, right? I think the full life cycle is as this, and if you're starting an ML project, consider number one, the scope of the project, right? Decide what you want to work on. What's the kind of problem you're looking to solve? What's the business use case? What is the area you're looking to solve? Is it solvable using AI, or can you utilize some reporting or visualization or something like that to actually address the problem that you've got there? So are you working on the right problem? And then work your way from that point onwards. Then you need to, number two, kind of look at define kind of how you're going to collect that data, what type of data preparation you need, what type of data, what shape do you want the data in, what type of collection are you doing with that data? Is it live data that's coming in, or is it batch data? Do you have the data pipeline set up? What governance have you got set up on that data, etc., etc. Do you have access to that data? Can you? Is it privacy, ethics, security of that data in good shape before you start using it? This is a really, really important part of the phase of the process, like when you of the process of running a machine learning and AI project. Because if you don't get this right at this stage, you're going to have a tough time trying to reverse engineer and bring things back to sort this out once you've gone ahead and tried developing a model. So once you've got that data aspect in place, number three then is to train the model, right? So sometimes error analysis will drive you to go back to improve the data set, and then after doing this few times, once you've gone back and forth, because you might need to improve your exploratory data analysis or your transformation of the data to actually get the result what you're looking for to train the model. You might need to do that a few times. It's more of an iterative process. Then you actually look to deploy that model. Once you're happy with it, you look to kind of deploy that model to production, and you get and then you may go back again to update the model or collect more data if your production performance is not up to scratch or where you like it to be. Now, um, what I'm trying to basically say here is that it doesn't end there either. It's a kind of iterative cycle which you've got to keep on top of as a journey rather than seeing it as a one-off cycle. So I hope this diagram has been quite useful for you in your project, and some of the kind of key topics and key things that we've discussed here will help you. One of the ways that where I've done this before, for example, is the use case or the case study I was trying to explain to you earlier on around that custom NLU or the data-driven conversational AI project that I built, where we did something very similar. But only, one of the key learnings from that project that I found was that you need to make sure that you have the data aspect sorted out and controlled and maintained, because that is going to be the most time consuming and the most laborious task that you're going to have to do within your process. And then the maintenance and the kind of cycle, and not just from a technology perspective, also think about the skill set, think about the budgeting, think about the cost and the ROI that you need to put in place to be able to run this as a skill. Think about whether you want to build versus buy, whether you want to build your own data scientist team, or whether what your gaps are, what your kind of SWOT analysis of your own existing organization look like. Think about those things when you're starting off and embarking on a project. Now, looking at some of the more kind of best practices and recommendations, there's kind of key differences between these two models, right? Model-centric view is a lot around where you hold the data fixed and iteratively improve the code and the model to gain efficiency and performance. Now, this might be okay for you if you have access to a huge amount of data, like a big consumer internet consumer company or other large social media organizations out there, where you have a huge amount of data and resources and budgets for this for you to run with this. However, you may also, in fact, you should also consider a more database view where you hold the model fixed and you iteratively improve the quality of the data you are feeding the model. So this is also, an approach which could be more useful for where you don't have a huge amount of data, and there are a lot of verticals, a lot of domains or areas where actually you don't have access to a huge amount of data, and this is where this could be really efficient and useful. Also, industries where there's not a huge amount of data readily available, this is also very suitable for them. And also, it's very good to look at a more data-based view for improving data sets that are kind of in a very good way of improving variance in the model and what have you. So these are some additional recommendations and guidance that you've got there. Here are some more recommendations in terms of what kind of tips and prep you could utilize for your data aspect, especially on the data side of things. So, as I've said, I've kind of emphasized this before in my talk, that removing or correcting bad data duplicates is one area where you need to make sure that you look at all the outliers, incorrect data, duplicates, you resolve those kind of challenges within your data. Standardizing and formatting data, just making sure they're in the right place. For example, how do you represent names, addresses, other information? How do you represent images, unstructured data, shapes, formats, color depth, etc., etc. Updating out of date data, information. They might be, they might not be in the right format or accurate, but might be out of date or might not be accurate, might be in date. So what do you do to transform that? Make sure you've got a handle on that. Reducing noise within your data. So images, text, and data can have noise, which is extraneous information or pixels that don't really help with the machine learning project. So data preparation is very important here. Normalization, data sampling, feature enhancements. Excuse me. All of these capabilities need to be appropriately considered in order for you to have a successful machine learning and AI project, in order for you to increase the chances of being successful machine learning and AI kind of adoption of these capabilities and these technologies to be utilized in your organization. Another Just to kind of finish off in terms of bringing it all together, and what I've done here is basically put together some key components or key building blocks for an effective data strategy for your AIML project and what have you. And it all kind of starts with the quality kind of pillar, or the quality component being in the middle, where you develop a data set that has appropriate characteristics to address your business challenge. You minimize bias, you offer training, good quality training, consistently training data labeled with a high degree of accuracy. And then you have a number of different blocks on top of that. So storage, for example, store and structure your data appropriately to support your objectives regarding your resilience, compliance, security, governance, acquisition and processing. So how are you acquiring that data? How are you obtaining and accessing the data you need to have to develop a effective kind of a prototype and algorithms? Context. It's really important to understand the provenance of your data and the mapping through which it passes through to show, so that you can share it effectively within your company. These are really important points that we have. Provisioning, right? Optimizing accessibility of your data to your team and the implementation of having safeguards on that data, right? Of how it's provisioned. And then to top it all off, like goes across everything, is your management and security, right? Management, data security is really, really important. Access and permissioning to ensure appropriate use of your data stores. These are all really, really critical, important building blocks that you need to have in place to have a higher chance of success with any machine learning and AI capability that you're trying to build within your business, or you're trying to adopt within your business. Define your data strategy from the outset of your AI initiative, review it quarterly. And again, this is a really important point, actually, is actually continuously reviewing your data strategy and your product requirements as things change, data changes, seasonality, environmental impact, disruptions. Look at in the last 2 years what's been going on. How are you making sure you've got the processes and controls in place so that you can keep the model up to speed and fresh with the data that you're trying to bring in, or the fresh data that you're trying to bring in for that model, so that you can feed it and keep it relevant to you as you grow your business. So just with that, I want to thank you for your time. I really appreciate you taking time out and listening to my keynote on maintaining focus on data. And I want to maybe take one or two questions, if there are any questions from the audience for that. But thank you so much for your time. I really appreciate you taking time out looking, and I hope to hear and connect and talk to you very soon. As a result of that, please reach out to me on LinkedIn if you want to connect and discuss any of these topics in more detail. But thank you so much, Joel. This is it's been a fantastic opportunity to share my knowledge and experience and expertise with the audience.
So much, Aamar. It was a great opportunity to hear that wonderful. By the way, I am very conscious about time. We only have less than 2 minutes. So what I would like you to do basically is to look on the participant question that we have pre-selected and select one question that could be the winner, and you can answer that question as well, if you don't mind.
Yeah, okay, let's have a look. Okay. Yeah, some really good questions here. I was so busy in doing my talk actually to have a look at this.
Go ahead. Take
Yeah, yeah. So, yeah, there's some brilliant. I think the. I think. I think the question around, what is the first stop on the journey in implementing AI and ML in any business setting? How will you define success of intelligent-based solution to quality of data? I think that's an interesting question. Yeah, I think there's some really good questions over there, Joel. But I like actually the question around big data. Um, big data having kind of synergistic relationship requires a massive scale of data to learn from, improve this. Yeah, for better analysis, what's this conversion? How can a company leverage advanced analytics capabilities to augment or predictive analysis? I think these are all fantastic questions, and I'm just looking at which is the best question I think here.
You need to select one because there is a one winner only.
Questions. I can tell you that I can come.
Can hear them saying, "Please choose my question. Please choose my question."
With Ciara Alaracon's question there.
Okay.
As good as the data you use to train them. So how do we build a comprehensive data study? I think I answered that question at the end in the last slide that I was going through. I hope that answered your question, Ciara, but I think I would go for that one. Let's go with that one, Joe.
Question. Shara, right?
Shara, yeah, that's it.
Congratulations, Shara Alarcon. You were selected by Amar. And Amar, any last word before we say goodbye to everyone?
Oh, well, thank you so much. And actually, I just want to thank Joel really and his team for doing a fantastic job here and setting this up. And also everybody that took time out to contribute and ask questions and get involved. We really value your participation and the time that you've given us. So thank you so much from everyone from our side, me and Joel, really, from Wow AI side of things.
So much, Amar. Please, another topic or keynotes from Bon Dolens coming up. Thank you, guys.
Thank you very much, guys. Bye bye now.